Hello.
Hi, Arat. How are you?
Good, thank you.
You are early today.
Yes.
You are not early, but early than usual. Usually you are late for a few minutes.
Hello, Mr. Chosun.
Hi, Narmin. Good. Okay, Arat, Narmin, you are here. We can start, all right. And others maybe will join a bit later, or we will see. Okay. Arat, maybe the last 5 minutes, I'm going to actually finish the class a bit earlier, maybe 5 minutes earlier. In the last 5 minutes, we are just going to have some discussion. And you sent actually that question, but I didn't understand. I couldn't remember what was it about. So I will ask again later, okay? And we'll discuss about this. And okay, so what are we going to do today? And let's try to finish these papers. Now we are in 2016 S2, and it takes 2 hours. And after that, we will do S3, and after that, we will solve questions from 2017, and after that, we will see 2018. Actually, I tried to find, but still I couldn't find. Mr. Arat, you're I think good with Mr. Google. If you could find Sasmo 2018 papers, please share with us. Okay, because usually
Okay.
finding Sasmo papers on the internet it's not easy. And this one actually, I just kept these papers when I organized Sasmo here, like 2015 and after 2016, 7 those years actually. I collected all of these papers and kept. Usually it's not given to anybody. All right. I'm just sharing with you, but finding on the internet is a bit hard. I don't know how can I find this. So if you can find Arat, let me know. 2018, 19, 20 papers, okay? And share it with us. So now you have actually enough experience, and somehow we have already actually, it is already, it is shaped about what is it, Sasmo type questions. When I just talk about Sasmo, somehow you can actually think of about something. They actually ask these kind of questions. If we have these questions, we need to approach this from this perspective and blah, blah, blah. And now we need to work a little bit on time, okay? Can you think fast and do the questions fast? Because now you know the method, you know the idea, most of the questions, you know how to solve them, but can you do it or not? Now that's another stage of preparing for the Math Olympiad. Now, first, you need to get some knowledge. And after that, to consolidate your knowledge, you need to practice questions. After you practice questions, you know the weapon, actually, you can just handle any situation. And after that, can you use it fast? Okay, that is another challenge, because just thinking is not enough. Just to be able to solve the problems, it's not enough. Can you do this fast? That is another challenge. Anyway, guys, let's continue then. Okay, so I'm going to give you just 2 minutes for each question. Please do it maybe at least for the first 10 questions. Okay, maximum 2 minutes. If you have the answer, just put it in the text box, chat box. If you have no answer, then we will just do this after 2 minutes together. Okay, especially I want to know what method are you using to solve the questions, guys. Okay, if you have no questions, we can start now. And you can start with the first question.
Is the answer none of the above?
Arat, can you write your answer to the chat box? Okay, and after 2 minutes, we can do that. Okay. Okay. All right. Let me keep this. Yes, Arat, you have the answer. How do you do that? Just quickly tell me your methods, and let's move to the next question.
Firstly, 9 times 1 is 9, obviously. Then 2 times 99, we get 2 times 100, and minus it by 2. So we do it, and we get that the first 2 digit is 4, and no, actually there's another way as well, but we get that
Yeah,
the
just
first
tell me
two
the shortest way to solve this question. This is a problem. Okay, in different ways you can solve this, but this one, okay, if it is a multiple choice question, solving multiple choice question, and also they have some techniques, right? Because if it's
first we
not a
find the
multiple choice
last
question,
digit and the first digit. The last digit is 0, so it cannot be C and D. But the
okay,
first digit is not
if you
1.
solve this, for this question, Arat, that is not the best methods. Okay, the best method is if you just look at the last one. This one is 10,000 almost plus times 4. That is almost 40,000. All of these numbers are less than even 12,000. So this cannot be equal to any of these numbers. So automatically the answer is E. Did you get it, Aras?
And not sure I went the same way, but I was saying like a little bit saying it a lot, but my way was the same.
But Matt, you are saying that the last digit, if you add blah blah, no, just 1 second. Look at the last one, and the last one is, as see here, the last part is almost 40,000, right? And we are just
I
adding
meant
some
the
positive
same.
numbers, huh?
It's when the last digit would be 4, but in here the last digit is 1.
Yeah, if you're comparing the last digit, that's not the best method. Okay, to get the last digit, you need to multiply all of these numbers and add them together. Only in that way you can see the last digits.
No, actually, you don't have to do that because if you do it by this, only the last one is affected because the one before is like 10 times 100 times these things.
I think you didn't get me, Arat. I'm saying that here we are sum, and you're just adding number. And all of this add-ins, actually, they are positive numbers. We are adding positive numbers here. And if you just look at the last summon, actually, if you look at this one, and I can just from here, I know that this one is greater than 40,000. And here, in the answers, none of the answer we have here more than 40,000, greater than 40,000. So that's just that observation is enough. That's forcing us to choose the last answer. Well, anyway, that's one method. You can choose different methods. It's okay. I'm just talking about how can you do this in the fastest way in multiple choice questions. If it is not multiple choice question, if you say that, all right, Mr. Qasim, here I can write this nines as 10 minus 1, plus next one is 100 minus 1 times 2, and that next one is 1,000 minus 1 times 3, and the last one is 10,000 minus 1 times 4. At the time, actually, I would say that, yes, this method is correct. If they do not provide the answers, the fastest way to calculate this one is this. As I say, here we have 10, here we have 200 and 3,000 and 40,000, right? So that means that here we have 40,000, 3,200. That is 40,000, 3,210. And after that, we should just subtract 1 minus 2 minus 3 minus 4, that's equal to 10. And subtract it, that's equal to 43200. Okay, let's move to the next question. All right, next question. Good. The answer is this. All right, you have 1.5 minutes for this question. given that x is an integer such that it is from -4 less than or equal to x is less than or equal to 3, and y is a prime number, find the greatest possible value of x squared minus y squared.
Teacher, is -1 a prime number?
Hmm?
Mm, is 1 prime number?
No,
So I changed my answer.
the smallest prime number is 2, right? Okay. Good. So here, since it is square, right, here either -4 or 0 or 3. Which one gives us the maximum value? Since it says the greatest value, and we are subtracting this, the first one must be the maximum. Let's say it must be in this form, maximum minus minimum. Maximum value of x squared, that's equal to -4 squared, that's 16. Minimum value of y, since it's a prime number, the smallest prime number is 2 squared, that's equal to 12. So the answer is 12. Okay, next question. Find the missing number x. I mean, why are you quiet today?
I don't know.
Are you tired, or you're not in the mood of school because you're on holiday?
Um, yeah, I don't want to do school, but I'll still do.
Okay. Yeah, I understand. Sometimes learning, right? After you finish your school or university, after that you miss learning, you miss your school time, you miss your university time or college time. And this is life. Anyway, Arad says, Arad, your answer 34. Why?
Firstly, for two reasons. First, once again, in here we have 12, then 23 is mean it was like here is 3, 4, 5 is when there is pattern like this. 12, 23 is mean plus 11, then another plus 11. Also, the gap between these two number is 4. In here is 2 because it's going like 1 square, 2 square, 3 square. And because it's then it go like this. 2 to the here is the gap should be 2 to the power of 0, 2 to the power of 1, and 2 to the power of 2. The gap.
I think, but these numbers, this one is squared number, this is squared number, this is squared number, squared number. So squared number and squared number, right? For example, what is 169? It is 12 plus 1 squared. And how about 16? 16 is 3 plus 1 squared. And next one, for example, here, 23 plus 1 squared, it is 576. And 4 plus 1 squared, that's equal to 25. Right? And I think this works much more logical. This one is 5 plus 1 squared. It is 36. Then here we have x plus 1 squared. It should be 64. So what is x? X should be 7. What do you think?
Agree.
Now I can just write for any rule then. If you're just given any number here, right? If you're given here a, then as b, that means that here we have a plus 1 squared, and here we have b plus 1 squared. Okay, so the answer is 7, Arats. All right. I think with a similar question before, and one more time, the year 2016 is an interesting number because it's divisible by 1, 2, 3, 4, 6, 7, 8, and 9. When is the next year? When is the next year that is divisible by 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10? Right? And to do this one, as you know, actually, we need to just find such number, right? That is a multiple of the least common multiple of these numbers. And quickly, if you just find the least common multiple of these numbers, and after that, we just say that one is the next year. So actually, all of these years, they come after 2021. And of course, one way is you should just check the smallest number here is, it is 2,520. It is divisible by 1 years, divisible by 2 years, divisible by 3 years, divisible by 4 years, by 5 years, by 6 years, by 7, 21, 42 years, by 8, it is 520, 50 to 48, it is 40 years, by 9, it is 4 years, by 10, right? Actually, 2,520 is divisible by all of these numbers. So the next year is 2,520. That is if we have the choice here, right? If we don't have at the time, we need to find the least common multiple of these numbers. And you know how to find this. And after that, see which one is the smallest multiple of this number among these answers. And in this way also, we can choose this. So that is 2,520. All right. Next question is for you. Arad, first, can you read the question and let's see. Maybe you'll try to do this first, and after that, we can do them together.
Einstein prime is a prime number which is one less than a multiple of 3. For example, 11 is an Einstein prime since it is one less than 12. How many Einstein primes less than 60 are there?
And the only way to answer this question is we have to write down these numbers, right? Do we have any other way? I don't think so. If you know, let me know.
None of the above.
None of the above. Why?
Because 6 is 3 times 20. It means there are 20 answers.
No, it says that Einstein prime is a prime number, which is one less than a multiple of 3.
No, teacher, I meant another thing. Like in here, 12. How many numbers are less than 12? 12 is 3 times 4. Is when we have 3, 6, and 12. It is the fourth one. 6 and 60 is the 20th one.
What say again, Arad? Without writing, how can you count here? How?
One less than.
Okay.
But you are doing one more than as well. It means this one should be crossed. This one should be crossed out. This one as well.
Now I'm just checking. Now these are the prime numbers less than 60.
No,
And it says that it's a prime number, which is one less than a multiple of 3. So this one is, what is it? 3 minus 1. It is yes. This one is no. And actually for no, I don't write anything. 5 is 3 times 2 minus 1. So that is also prime. And this one is 3 times no. And this one is 3 times 4 minus 1. Yes. This one is no. And this one is 3 times 18 minus 1. Yes. This one is no. 24. And the 30. 30 minus 1. So that's yes. 31, 37. No. 41. Yes. 43. No. 48. Yes. 54. Yes. It is 53, 54. 18, right? 18 minus 1. That's correct. 59, 60 minus 1. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we have 10 Einstein numbers less than 60. So the answer is 10. Okay.
Okay.
So why do you say none of the above?
I forgot that it is prime.
You forgot? As if you read this question 1 year ago and you forgot. It's just here on the screen. So that's
No,
why you
I
need to
thought
read
it can be
twice.
any number which is less than one multiple. I forgot it has to be prime as well.
Very good. That's why, Arat, you need to read the word problems twice, every time, at least 2 times. First, write quickly to get the idea. Second time, a bit slower. Try to understand every keyword related to the solution of the problem. Okay, let's move on. Javid, are you here?
Yes.
Javid, where are you now? At home or outside? Okay. How would the pattern appear when the transparent sheet is folded along the dotted line? Narmin, what do you think?
I think
Arat,
it's.
I got your answer. Huh? Say again, Narmin.
Is it A?
Is it A? Why?
I don't know. It looks like.
And Arat says C. Java says nothing. Eldar says nothing. Eldar, do you have any idea?
No.
Okay. Anyway, how would you do that? It's a kind of, actually, we call this reflection, right? So we need to just find the image of this figure along this line. So this one is the line of symmetry, right? To do this one, actually, first we need to just reflect the points and join them. And so this one, if we reflect this, it will be somewhere here, right? With the ruler, you can do this much better. And this one, if you reflect this, it will be somewhere here. It's a bit inside, maybe it's
I
here.
notice it.
And this one, it is here.
It would be here.
And this one, it is here. Is it? Are they
This one,
same?
yes.
The length. If they're
And
same,
if you see this line is completely in half.
okay. So at the time, if we just reflect this, right, join the points here. So we just join these points and these points, and after that, these points, and after that, these points. And also, we just join actually, okay, here. Right. So what is it? It is just C. If you're doing, actually, this one is paper-based in 2016. If you have a ruler, just put your ruler. It has 4 points, right? Just plot the reflection of these points, and after that, join them together, and you can just see the picture. It is very easy question. So it is C. Javid, can you read the problem?
Two 10-sided dice with numbers from 1 to 10 on their faces are rolled on their face values multiplied. How many ways are there such that the product is a prime or ends in 6?
Okay. It says two 10-sided dice with numbers from 1 to 10 on their faces are rolled and their face values were multiplied. Right? Maybe because, anyway, how many ways are there such that the product is a prime or ends in 6? Right? So product ends in prime. What does it mean? It means that here either the first number is 1, the second number is 2, right? Or the first number is 1, the second number is 3. Or the first number is 1, the next number is 5. And first number is 1, the second number is 7. And I think that's it, right? Because it cannot be the first number 1, because if it is any other number except for 1, it will not be a prime number. So actually, I can just write the same thing for the second die, right? Also, we have this possibility. It is 2 and 1 and 3 and 1 and 5, 1. And instead of writing this, just let me just find this. And after that, I will multiply it by 2. So how many? It is 2 times 4. That is 8 ways. And also it says that how many ways are there such that the product is a prime or ends in 6. So we need to count them together, right? Product of 6 is, first it is 1, 6, right? And it is 2, 3. What else? And if it is 2, also we have
Opposite.
2. It says such the product is prime or ends in 6, right? It should be 2 and not 4, 5, 6,
3
7,
and 2.
8. 2, 8, right? 16. Not 2. And after that, what about 4? For 3, 3 times 1, 2. Oh, no, it never ends in 6. So here we have 4. We have 4 and 4. And here we have 4 and 6, right? No. 4 and 6, 24. So what is next? And 36, right? 4 and 9. And that's it. How about with 5? No. With 6, here we have 6 and 6. And what else? 7 and 8. 7 and 8. 7 and 8, 56. Do we have any other way? No. And also here, how many ways? Here we have 1, 2, 3, 4, 5, 6, 7, right? So that is 7 times 2. It is 14. But actually, this one, 4 and 4, it's the same thing, right? 6, 6, 6, 6, the same thing, because 2, 8, 8, 2 is different, but 4, 4, it's the same thing. That's 14 minus, I need to subtract this. I need to count them as 1. Others, 2. So minus 2, so that will be 12. So altogether, it says or. That means that the union, right? So let's say this one is, let me just call this P something, and this one is divisible by 6. So we are finding this one, right? The number, what is it? Number of P union 6. Right? Anyway, so here altogether, how many? It is 8 plus 12. The answer is 20. So we have 20. There are 20 ways such that the product is either a prime or ends in 6. Is there a question or answer? Arat, none. What do you mean, Arat?
I meant none of the above.
For question 7?
Yes.
Why?
Mistake.
Okay. So it's 20. Anyway, let's move on. What time is it? Okay, so we have time. Good. Guys, try to do this. Okay, you have 2 minutes. How many factors of 9 are perfect squares? I think we did a similar question before. So you have 2 minutes for this question.
Is
Eldar,
one
let's see if you
perfect
can do this
square?
question. Huh?
Is one perfect square?
Of course. Perfect square means it's what is it? The square of a natural number. So that is 1 square, 2 square, 3 square. These numbers are called perfect squares. The smallest perfect square is 1. Eldar? Eldar,
Yes,
what are you doing right now, Eldar?
nothing.
Then why are you here then?
No, I mean, I'm solving this question. I'm trying to find how many squares it has.
You are so quiet, Eldar, as if actually, I don't know, just want to watch something and you're bored. That's why you joined the class. I don't know. It's interesting. Do you really actually want to study math, Eldar, or because your parents want you, that's why you are here? Why are you in this class?
I don't know.
You don't know. Yeah, that's what I was expecting. Okay, Eldar. Guys, any answer? Arat, Narmin, Javid, Eldar.
7.
How many?
7.
Yeah, I was expecting this, Arat.
9. 8. No, actually, I found 6, but still, because. Can you give 30 more seconds?
Javid, can you tell me your answers? What are those numbers? Because Javid found 8.
Yes, it is 1, 4, 10. It's
I found
9.
8.
You found 8?
Yes.
Okay. Okay, Javid, you can just say Here, the idea is very simple, right? Here, we need to first find prime factorization of this number, and that's 0, 0. Divide by 2, it is 4, 9, 0, 0. Divide by 2, it is 2, 4, 10, it is 5, 0. Divide by 2, it is 1, 2, 2, 5. And 4, 5, 10, it's not divisible by 3. And divide by 5, it is 2, 4, 5. Divide by 5, 24, it is 4, 45, it is 9. It is 7, it is 7. So 7, it is 1. So these are actually first 1, and this one is here. We have even number of 2s, that's why it is 4. And after that, even number of 5, it is 25. And even number of 7, that is 49. So these are 1 and 4, 25, and what is it? 49. And after that, if you combine these two together, right, it is 4 times 25, that is 100. And after that, if you just combine this together, it is 14 square, 14 square, that is equal to 196. And if you combine these two together, that is 35, 35. Let me just write here 35 squared. And after that, 1, 2, 3, 4, 5, 6, 7. And one more thing, on purpose, actually, they are choosing this number. And also, can you just see the triple, right? That is 2 times 5 times 7 squared. Because we have actually 2 2s, 2 5s, 2 7s. And also actually the product actually divides this 980. That's equal to 70 squared. That's equal to 4900. So how many altogether? It has 8 factors which are perfect
Teacher,
squares.
you forgot about 16.
16?
Yes.
What do you mean 16? 16 is not a 16 not is a factor. Yeah? How can you get 16 here?
4 times 4.
But do we have 2 4s here?
No.
We have only 3 2s, right? So we cannot form 16 from these factors. Okay, so answer is 8. Good, Javid. Let's move to the next question. Javid, can you read this problem? Let me have some rest while you read this problem.
In mathematics, figure 1 is called manager sponge. The construction of manager sponge is described as follows. First, begin with a cube. Second, subdivide the cube in 27 smaller cubes. Remove the smaller cube in the middle of each face and remove the smaller cube in the very center of large cube, leaving 20 smaller cubes. If the surface area of cubes in step 1 is 216 centimeters squared, what is the surface area of manager sponge?
Okay. Interesting question. It's called manager sponge. The construction of manager sponge is described as follows. Begin with a cube. Okay, here we are given 3 by 3 cube, and subdivide the cube into 20 smaller cubes. Okay, it's 27, right? Because we have 3 by 3, so here we have 27 cubes. All right, and remove the smaller cube in the middle of each cube face. Remove the smaller cube in the middle of each face. And remove the smaller cube in the very center of the larger cube, leaving 20 smaller cubes. If the surface area of the cube figure 2 in step 1 is 216 centimeters squared, what is the surface area of manager sponge figure 1? Okay, is the question clear, Arat?
Yes.
I think it is not so hard question if you understand, right? Because just we are removing, right, from each face of the cube. Now in the first step, we need to find the surface area of the first cube in figure 2. And after that, we are just removing this. Each face, as you see here, it has how many cubes? It has 6 cubes, right? 1, 2, 3, 4, 8. It has 8. 8 or 12? 6. Why is it so, Arat?
Because
Javid B. Arat B.
firstly, I divided 2001, 216 by 6, so to one second, to find the area of this one, which it was 36, and in here we have 9 cubes, and then divided by 9, so it becomes 4. So then we go to count the phases. 1, 2, 3, 4, 5, 6, 7, 8. We have 8. Because each face is 4, so I put 4 outside. 8 times, we have 6 faces, so 6. Plus, then we have this one, which is inside. This one. And also there is here, here, and here. So we have 4. And again, we have 6 faces. So times 6. And in here, we get 48. And in here, we get 24.
Okay, thank you. Good.
And then,
Because here again, once again, here the main problem is understanding the problem. Okay, because sometimes when you just say that surface area, what do we mean by that? Okay, so usually when we just say surface area, it is the surface of a solid that is in contact with air, right? That's what we understand from surface area. The surface area is this. Once again, the surface means it is the surface of any solid that is in contact with the air, the outside medium, let's say. And in the question here, it says that remove the smaller cube in the middle of each face, right? This one I see here in the picture from the first one, we are removing this one, this cube, and also we are removing this one and also removing it from the center. Number one, remove the smaller cube in the middle of each face. And the second one is, and remove the smaller cube in the very center of the larger cube. As see here inside, by the middle one, we have 1 in the center. Also, it is removed, leaving 20 smaller cubes, right? From each face, we are removing 6 faces, 1 more from the very center. So 7 cubes are removed. So if the area of the cube is in step 1 is 216, so that means that here we have, what is the surface area? The surface area is equal to, this one is 216. That means that 216 is 6 times 6 times 6, right? So that means that actually the length of each cube here is, it is 2, 2, right? So the surface area is, I can find this. Okay, I don't need it for now. The area of one face of this square is 2 times 2. That is 4 cm squared. All right. So now we know that actually this cube, it has 6 faces. That's why the total surface area will be 6. And in one, how many squares do we have? 1, 2, 3, 4, 5, 6, 7, 8. And here to the left, right, touching this one, it is 9. Touching this one, the common part, it is 1 more. Touching this one, the other side, and the other side, this one, right? How many? 4 more. So here we have 12. And 12, and the area of each face, there is square, that's equal to 4. So that's equal to 72 times 4, that's equal to 288 cm squared. So the area is 288. All right, that's it. Let's move on. Next question. All right, in the diagram below, ABCD is a square, and CDE is 84 degrees as a C, and DCE is 48 degrees. Find the angle EAD. What is A? EAD. Okay. Guys, give it a try. Maybe 1.5 minutes after that. Let's do it together. Okay, how do we get it, Arat?
Firstly, I found one second. Firstly, I found this angle E. 180 minus 84 minus 48, which is 48 degree. So this is isosceles. So this side is equal to this side, and also because ABCD is a square, so this side is equal to this side as well. So triangle AED is isosceles as well, and because it's a square, here is 90 degree. So we get 180 minus this angle, which is 174, we get 6. Because it is isosceles, so this one is equal to this one. Divided by 2, we get 3.
Okay, good. So Javed, the answer is 3. What Arat says, it's not 8. Because from here, right, this 84, 48, what is this angle? That angle is 180 minus 84 minus 48. That's equal to 48 degrees. Now from here, that means that actually 48, right, this side is equal to this side. So that means that, and also this side is equal to this side. So if this angle is x, and also this angle is x, and we know this is square, this angle is 90 degrees. So 2x plus 90 plus 84, that's equal to 180 degrees. Now from here, 180 minus 9 is 90. What is 2x? 2x equals 90 minus 84. So x is equal to 6 over 2. That's equal to 3 degrees. All right. Which of the following statements below is true? The number of false statements here is 1. The number of false statements here is 2. The number of false statements here is 3. The number of false statements here is 4. The number of false statements here is 5. Narmi, what do you think about this question? You are good at logical questions. Why is it 4, Arad?
Because in here, when it says which of the statement below is true, when because it is multiple choice, so there has to be one answer. So it means 5 minus 1, 4. Because firstly, it cannot be E because it's been all of them are lies, so there's no correct answer. But there has to be one. There is one false. It's been 4 of them has to be correct, including it maybe itself and the others, but the others doesn't each other. It's been they're not true. If it be 3 again, it doesn't match. Like it's a one of them say false. Like we have one false, we have 2 false, so they don't match. The same thing for 2, but the only thing when it said there are 4 false answer is when 4 of them are wrong, only one of them is true because they don't match to each other. There has to be only one answer.
Good. So here we have 5 options, right? It says that which of the following statement below is true. So it says that one of them must be true. That's why here we have 5 statements. If D is true, the number of false statements here is 4. Right? It means that if it's telling the truth, all others should be false. So that's telling the truth. So here it can be only number D. Good. Anyway, let's move to the next question. These are logical questions. Sometimes, if you really want to understand, you have to read and think. It's not so. What is it? Anyway, that's another question. It's about coloring a map. We know that in the world map, right? And sometimes countries may have the same color, but they don't have any border. I mean, they don't share their borders with each other. Otherwise, it will be confusing. So usually under this condition, we can color the map. Okay, similar question here. There are 13 regions in the diagram on the right. Each region is to be painted with one color. What is the least number of colors needed to paint all the regions so that any 2 adjacent regions do not share the same color? All right. Javid, are you here?
Yes.
What do you think, Javid? Actually, before we continue this, Javid, if I ask a question, if you are tasked, let's say, to color this map, where would you start coloring this map? From which region?
From the middle.
From where?
Middle.
What? What do you say, Javid? Javid, can you say again? I didn't get it.
Middle.
Middle. From the center, I mean. Okay. Good. As usual, Arad, you say D, 5, 4. Are you going to decrease your answer to 3? Or that's your
No.
final answer?
And no, at first I wanted to do 4 as well, but it was typo. Then when I reached, when I like do again on the chat, it was suddenly 5. But my from beginning it was 4.
Usually in this kind of questions, we have to start coloring from the region where it has border to most number of other regions, right? As you see here, the center, it has a border to how many different regions? If I just start from here, let's say we have different colors, color number 1, color number 2, color number 3, color number 4, and 5, continue. So I just start with the first color. Here we have color 1. And see here it's border 2, 1, 2, 3, 4, 5, 6. So now I cannot use 1 here. So let me just color use 2. So here we have a 3. Now it is border to 1, 2, 3, but I can write here it is 2. And now 1, 2, 3, and here we have also I can write here 3, and 1, 3 I can color here 2. But now I cannot write here 3. It is 1, 2, 3, 2. It is 1, 3, 2, right? So it is 1. Can I put here 3? Yes. Is it 1? It is 1 2 1 3 3 2 2 3 3 2. And how about here? Here we have 3, right? And if it is 1 3, let's say it is 1. All right, can you delete them? Because if you highlighted, it will be so confusing. Okay. 1 2 3 1 3 2 1 2 3 1 3 2 1 2 3. Is it okay? Now it is 3 2. I cannot put here 1, right? The only thing I can put here is only 4. So here we have 2 3. I can put here 1 2 3. I can put here again, what is it? 4, for example. 3 2. I can put here 1, and 2 3 and 1. I can put here 4. So as see here, minimum, actually we have to use 4 different colors to paint this pen, because 3 is not possible. If you try to do 3, it is not possible, right? Because I see here, one border, for example,
Actually, we can.
this one, right? For if you look at this, it is bordered to this, it is bordered to this, it's bordered to this, it's bordered to this.
Actually, we can logically.
Logically,
Yes, we can
no.
mix the color so we get a new color.
So that's new color again.
No, but we use the 3 colors.
All right, actually, we produce other colors by mixing other colors, right?
Yes, but it said how many colors did you use? So we used 3.
So if you mix, for example, green and blue, you have new color. That is also it has also another color. We
But
don't
we
call this
didn't
a
use that
mixture
color.
of 2 colors. We just call this another color.
Yes, teacher, but we name it another color, but we used 3.
Okay. At the time that it will lead to a lot of confusion. That's why in life, when you are setting a rule, it must be simple, understandable, and easy to apply. Okay. If you just say that, okay, how much you are adding, okay, depending on the amount of addition, also they produce some different colors. At that time, we'll just need only 2 colors then. Anyway, no problem. Guys, thank you very much. That's enough for today. Enjoy your holiday. I will see you next Tuesday. Okay. Thank you very
Bye.
much. See you.
Goodbye.